Hello, everyone, and welcome to the next lecture in the School of Solana. Today's lecture is going to be about the SPL token program. The content of this lecture is as follows. Firstly, I will quickly introduce what SPL is and what the most important accounts within the token program are. Then we will proceed into the hands-on example, which will have basically two parts. The first part will be about the escrow program structure, the motivation behind the program, and how it can use the accounts and methods from the token program. Then the second part will be about coding, where I will show you how to work with the token program within your dApp or briefly within the client side or test side. So now let's move on. So what is SPL token program actually? Firstly, at its core, the Solana Program Library is a set of programs. Then further, token program is just the program within this library that provides a framework for creating and managing tokens. Then those tokens can represent basically anything of value from crypto, from digital assets, stable coins, and are fundamental to the functioning of DeFi or decentralized finance. They can be used as non-fungible tokens and more. Then there is the basic structure. As I said, I'm going to talk about the most important accounts. So key features and components. You can see in the middle there is the mint account. And the mint account in the world of the SPL token program act as a blueprint for tokens. The mint accounts define the rules and properties of a specific type of a token. Key attributes of the mint accounts include the total supply, as you can see within the data field here, that's the supply, the number of decimal places, let's say 9, 6, then the authority responsible for minting new tokens. That is the mint authority field. Mint accounts actually provide the foundation for the token creation and supply management. Then we have token account on the left-hand side. Token accounts can be thought of an account designed to hold a particular type of token. These accounts store essential information such as the token balance. You can see the amount, which is basically the balance. The owner's wallet address, that's the owner public key, and the reference to the corresponding mint account. Okay, that's the mint public key. Lastly, sometimes you can bump into something called associated token account. And associated token accounts are essentially token accounts with the same data contents as a regular token account. Okay. In contrast, a token account can be created at any address using a program-derived address or a common key pair. However, associated token accounts have predefined rules for creation, with their addresses being derived from the mint public key, so this data field, and the owner public key. This distinction then leads to a situation where you can have multiple token accounts for a specific token and only one associated token account for that same token, because mint and owner will be always the same for one owner and one mint. With all the information in mind, let's now move on to the hands-on example of the escrow program. So before I start actually coding, I want to quickly go through the explanation of the escrow program, the workflow of the program, and what is it, why is that. Firstly, let's say you want to exchange euros for dollars. So for this example, we can say that you are on the Alice side and you want to exchange euros for dollars with Bob, or let's say it's not your honest friend. The question actually is, who is going to send the payment first, because if you send the payment first, so you send the $10 and you want to receive you send the 10 euros and you want to receive $20, Bob can actually scam you and run away from the exchange, so you are now 10 euros in minus. This is the problem also for the other side, so you can basically, let's say, scam Bob. The goal of the escrow program is to solve this problem. On one hand side, we have Alice with associated token account for tokens X, in this example euros, and associated token account for tokens Y, in this example dollars. On the other hand, we have Bob, also with the ATA for dollars and ATA for euros. And now the workflow. Firstly, Alice is going to initialize the exchange with the escrow program. That means initialize exchange is basically a method within the escrow program, and this method will create an escrow token account for tokens X, or in this example euros, and we can also call it the vault. Then this method will also transfer tokens from Alice's associated token account for euros into this escrow token account for euros. That means the euros are basically locked here, so she cannot run away with the dollars. Then we have basically two options. One option is that Bob decides not to accept the exchange. Alice then can close the exchange and withdraw the balance from the escrow token account. That means she won't lose anything. Alternatively, Bob can proceed with finalizing the exchange. This method will firstly transfer dollars from Bob ATA for tokens Y or dollars into this ATA of Alice for dollars. That means Alice received the dollars. Then, second step, the method will transfer the method will transfer euros from this vault or escrow token account into this Bob ATA for euros. That means Alice received the dollars and Bob also received the euros. Last two steps, we can, not we, but the method can remove unnecessary accounts such as the escrow account and escrow token account, because as I said, exchange is finalized, so we do not need those anymore. Now, if you stop and think about it, Bob has only two options: either not to accept the exchange or to accept the exchange without the opportunity to scam you. This is because exchange finalization, right, the method for finalization exchange, automatically trigger the transfer of dollars. So there is no option like, I want to receive euros but not transfer dollars. Within this function, he has only two options. One option is that transfer dollars and receive euros. Second option is not to finalize the exchange and he won't receive anything. As you may see, I'm sharing lib.rs. For this lecture, I in advance implemented escrow program template, as you should be already experienced with the basic Anchor structure or Anchor project structure. So that means we have lib.rs, which is basically entry point to our escrow program. Our escrow program expects three functions, as I was talking about those within the workflow part. Those are initialize exchange, finalize exchange, and cancel exchange. Further, first initialize exchange also expects three input parameters or three input arguments, and those are A to B amount, B to A amount, and side B. Then I want to clarify that in this context, actually side A is Alice, side B is Bob, then A to B amount is the amount we want to exchange from Alice to Bob, and B2A amount is amount we want to exchange from Bob to Alice. Okay, then there is the state.rs file, which defines escrow structure. This structure is going to be used within the escrow account data field, and the structure contains public keys of the sites, then the amount we want to exchange, then there are the means. The means are important in order to create a sufficiently unique program-derived address. And as I said, we are going to use program-derived address. That means we need to store bumps. Let's move on into the initialize exchange function or file. Firstly, within the instruction macro, we are specifying that we want to use A to B amount, B to A amount, and side B from the function input arguments. These variables are going to be used within the program-derived address of the escrow account. Then side A is expected to be a signer because the Alice actually needs to approve that she wants to make the exchange with the Bob, so she needs to actually sign the transaction. Further, as we are going to transfer tokens from her token account into the escrow token account, we need to delegate the signature into the cross-program invocation context. So these are the two options that for her to be signer. Further, she needs to, her account needs to be mutable because she's going to pay rent for the initialization of escrow account and escrow token account. So we need to modify her balance. So that's why her account needs to be mutable. Then we have escrow account. This escrow account is going to be initialized as specified here. Then, as I said, payer is going to be side A or Alice. Then we need to specify the space we need to use, or we are going to allocate within the data field of the freshly initialized account. Then there are the seeds. As I said, we are going to also use mint or mints within the seeds, and same goes for the amount we want to transfer. This is because, let's say, we do not include those fields within the seeds of the PDA. Rather, we use only those two. This would mean that at the time, we can create only one exchange between A to B, right? Because then another exchange will create same program-derived address for escrow, and that would mean, because obviously side A and side B would be the same public keys, that would mean that we cannot create next escrow account because we have already initialized previously escrow account on this program-derived address. So that means in order to create sufficiently unique address, we need to specify more variables. So in this example, I'm going to specify also mints, and I'm going to specify also amount. Then we have those two accounts, and firstly, side A send token account, as I have shown you before, it's this account, and it's actually associated token account of Alice. So we need to specify that we are expecting an associated token account. We can do it with the account macro, and within the account macro, firstly, we need to specify that this account is going to be mutable in order to modify the balance of the token account, because we are going to transfer tokens from this token account or associated token account into the escrow token account. Next, there are two important constraints in order to tell the anchor that this is associated token account, and in order to tell the anchor that, as I said, associated token account have has its address derived from the owner public key and the mint public key. So we need to tell Anchor that, look, this account is going to be associated token account. So check if the rules for the address are met. So we can do it this way. Specify associated token, then mint is going to be A to be mint, and the next input or the next seed for the associated token account address is actually the owner, or in this case it is called the authority, but it's the same. And authority, sorry, not authorized, authority, and this should be side A. Okay, so right now we are telling the Anchor, look, this is going to be associated token account, so use those two public keys, aka a public key for mint and a public key for side A, derive a program derived address from those two seeds, and check if the addresses are equal. As you may see, we are getting error here, cannot find the token account in the scope. So this means in order to work with SPL token program, we need to specify a dependency for that. So let's go to cargo.toml, and as we are working within the Anchor, we need to specify Anchor SPL equals 0.28.0. This will provide necessary structures and functions in order to communicate with SPL token program. So let's get back into initialize exchange, and now we can use Anchor SPL token account. Okay, let me drink some water. And let's move on. So right now you can see that we are not receiving error anymore for the token account. So let's move on into the escrow token account. The escrow token account in this example is not going to have the address for the associated token account, but we are going to create program derived address for this token account. Next, as I said, for the exchange, we are going to initialize this token account. That means we need to also specify that we want to actually initialize the escrow token account. So we can do it this way. Again, we need to specify account macro, and the inputs are init, then payer, which equals side A, as I said. Alice is going to pay rent for escrow and escrow token account, and it's not a problem because she won't lose any Solana, because within the cancel exchange or finalize exchange, we are actually going to close those accounts and the rent will be refunded back to Alice. So that means the rent she paid for the initialization, or the fees she paid for the initialization, she will get refunded later on. Then this is quite different from the escrow account, because in order to create escrow account, we need to specify space, because Anchor does not know in advance how much space we want to use. But on the other hand, as we have specified here that this is going to be token account, and data within the token account has or have deterministic size, that means we do not need to specify actually space, because the size of data within the token account is always the same. Rather, we need to specify to which mint, or the tokens of which mint this token account is going to hold. So that means we need to specify A to B mint. Then we also need to specify authority of this mint. And here are the three options for the authority. First option is let's set the authority as Alice, then let's set the authority as Bob, and lastly, let's set the authority as escrow. And we cannot set the authority as Alice, because that would mean if we want to finalize exchange, in order to transfer tokens, the locked tokens from this account into the Bob's account, token account or associated token account, the Alice would need to sign the transaction in order to be able to transfer the tokens, because authority over associated token account always needs to sign the transaction if you want to transfer tokens from the token account. On the other hand, if Bob is authority over this token account, that would mean that Bob can withdraw tokens from this vault or from this token account without actually sending the dollars to the Alice. So the result would be that he actually scammed her. So that's why we have escrow here. Lastly, we are going to specify seeds because, as I said, we do not have specific rules for token accounts or for address of token accounts. In order to recap, we have token account, which can be created on whatever address. So we can use actually PDA, we can use regular key pair. On the other hand, we have the associated token account, which can be seen here. And here we are specifying actually the seeds for associated token account address. On the other hand, for the token account, as I said, we do not need these rules, or we do not have these rules, so we can use actually PDA. And as I said before, the PDA for the escrow is sufficiently unique, so that means I'm going to use, for this example, I'm going to use escrow public key as seed for this PDA. Lastly, we need to specify the BAM. And I'm going to drink coffee, so sorry guys. Hopefully I'm not noisy with my sipping. Okay, so we are done with the context. No, we are not done yet. You can see we have mint accounts here, and for those accounts, we do not need to actually specify any kind of constraints. One thing that we need to specify is that we need to include the mint from the Anchor SPL as I made for the token account. So let's include the mints. We need to just actually, we are including the mint. We can check what the mint means. And this is actually public structure. So we are telling the Anchor that we expect the mint account on the address provided within the context. So Anchor will check that this is or this account has correct structure within its data. Same goes for the B2A mint, and you can see last error cannot find type token. So this goes as same for the mint. So we need to specify also token, and this token program actually, why we need to specify the token? This check ensures that, Anchor will check that the account specified at the last field of the context is actually program, and the program is actually token SPL. SPL token program. Why we need to use token program within our context? Because we are going to transfer tokens from token accounts, and in order to use transfer function, which is from SPL token program, we need to use we need to specify this token program within our context. So let's move on inside the function body, and as I said, firstly we need to initialize this escrow, and secondly we are going to transfer tokens from Alice to the escrow token program, escrow token account. So let's first initialize values within the escrow account. That means we are going to specify the escrow variable, which is actually pointing onto the or into the escrow account. Now let's fill the variables. Same goes for the side B. Then we have the amounts. Same goes for the amount, for the receiving amount from the Alice perspective. Then we need to store the means. A to B mean equals context dot accounts dot A to B mean dot key function will return basically public key. So we are storing public keys within these variables. Same goes for the receiving mean from the side A perspective or Alice perspective. Lastly, we need to store the bumps of the program direct address. So escrow dot bump equals, and we need accounts. Sorry, not accounts. Bumps dot get, and we need to specify the key for the hash map, or I think it's hash tree. And the key is actually the variable name, so escrow. And now let me copy the variable name of the escrow token account. And don't forget to update this variable, as this is going to be escrow token bump. Okay, so right now we successfully initialized the variables within the escrow account, and now we are going to perform the transfer from the Alice's ATA or associated token account to the escrow token account. So let me open the Obsidian. We are going to perform transfer from this associated token account into this freshly initialized escrow token account. So for this, we need to specify transfer function from the Anchor SPL. And this transfer function will actually call transfer function within our token program, but we obviously need to specify that we want to invoke function with from token program. We need to specify it in this way: cross program invocation context new. Then there is the program, so this is the public key of the program we are going to call. That's the context dot accounts dot token program, as I said. To account info, to account info. Then we need accounts. For the accounts, we need to specify the structure we are going to use, and the structure name is almost identical because it's called transfer. And within this structure, or this structure has fields as follows: from, which is context dot accounts dot side A sends token account to account info. I will recap this structure. 2 is accounts, escrow token accounts to account info. We are basically now specifying the context for calling the program. It's almost the same as specifying the context within our program, okay? And authority is Alice. Lastly, we need to specify what amount we are going to transfer. So actually, this is the A to B amount. Okay, so let's recap. We are calling transfer function Within the transfer function, we need to specify the CPI context. The context needs to contain which program we are going to call. So we are going to call token program within the SPL. From the context perspective, as I said, this ensures that the program is correct because Anchor will check that the public key provided within this field on the input or on the client side or within the test side, that the public key provided here is actually SPL token program. So that means it's safe. Then we need to specify the account structure or transfer structure that will tell us the transfer function that we want to send tokens from side A send token account, or aka the associated token account of Alice. Then we need to specify two. So we are sending tokens from this account to this account. This is the escrow token account, which was freshly initialized. And there is the authority over side A send token account, which is side A. That means the Alice. Lastly, we need to specify the amount. And as you may remember, I said side A needs to sign the transaction because she is the authority over this, over this token account. That means the signature or the privileges are going to be delegated from this from this context inside this cross-program invocation context. Okay, we are complete within our initialize exchange. Then we can proceed into the finalize exchange. And you may see initially that these are the identical errors for the dependencies. So let me just copy the dependencies here. And as you may see, the structure is basically the same. We have finalize exchange and there is the finalize exchange function. So we are going to implement the exchange, and I'm going to talk about the context. So firstly, finalized exchange is going to be signed by side B. Firstly, the side B is not required to be mutable account because side B is actually not going to pay any rent for anything. And again, the side B or Bob needs to sign the transaction because we are going to transfer tokens from his token account, from his associated token account for dollars into Alice's associated token account for dollars. And Bob is authority over this token account. That means he needs to sign transaction in order to delegate the privileges for the cross-program invocation context. Actually, that's the same as we were doing within the initialize exchange function. Next, as I said, within finalize exchange, we are going to close the escrow account. So that's why you need to specify close. And side A is going to receive the rent. That means, as I said, Alice won't lose any Solana for rent. So yes, she will receive the rent back. Then the account is or has to be mutable in order to close it. Then these are the seeds. And lastly, we check that the BAMB is correct. Then there is the side A unchecked account. This means that there are no checks performed on this account. And the account is marked as mutable. It would be safer to use side A as a seed in this example. So why this account needs to be mutable is because we are going to transfer or modify balance because we are transferring the rent back to Alice. So the account needs to be mutable in order to modify the account. Then we have constraint for the associated token account. This is actually the same as for initialize exchange, but the variables are different here for the corresponding authorities and for the corresponding means. This means this is side A receive token account from the escrow structure. It actually means that this is this receive associated token account. Authority over this account is Alice, aka side B, and this token account is tied to this mint. That means this token account holds tokens of this mint, aka the dollars. Okay. Again, the account needs to be mutable in order to modify the data or the amount within the token account. Actually, in order to perform the transfer, which will modify the amount. Same goes for side B receive token account. There are the corresponding mint and authority pub keys. Then this is the I'm talking right now about this is the side B send token account. This is the side B receive token account. So from this token account, we are going to perform transfer to this token account, and from this vault, where are the locked euros, we are going to perform transfer here. So we just need to check that the mint is correct, and then the authority is also correct. Lastly, we have escrow token account. As I said earlier, we are going to close this account, so we are going to transfer rent to Alice or site A. That means the account needs to be mutable. Further, we check that the corresponding mint is actually correct. Again, we check the authority is also correct, and they set for escrow. There are the seeds necessary for deriving the program derived address, and here is the saved bump. Lastly, as we are going also to perform transfer, we need to, or SPL token transfer to be exact, we need to specify that we are expecting token program inside our context. So let's work on function body. So as I said, firstly, we are going to transfer dollars from this associated token account into Alice's token, or sorry, Alice's associated token account to be exact. So for this purpose, I can just copy this transfer and alter or modify the from to an authority. So firstly, sorry, this is cancel exchange. I want to make it within finalize exchange. So transfer. Context is the same, token program is the same because we are invoking token program transfer. Here is the from account, but this time we are transferring from side B send token account into side A receive token account. Authority here is the Bob or side B. So he signed the transaction. The privileges are going to be delegated within this cross-program invocation context. That means this transfer is going to pass. Again, we need to specify variable that will hold data from escrow, or hold, I would say, read. So context.account.escrow. So we can use those data in order to perform transfer. So we can read, and there is no A to B amount, or rather B to A amount, because again, we are transferring from this token account into this token account. So that means we need to transfer B to A amount, not otherwise. Next, we are going to, okay, I can open it again. Next, we are going to perform transfer from this escrow token account into this associated token account. For this purpose, I can also just copy this transfer. And firstly, this transfer is going to be performed from, as I said, escrow token account, this time into side B receive token account. But as you may remember, authority over escrow token account is escrow. There is the amount we are going to transfer, which is A to B amount. Okay, and right now, before I deep dive into the transfer, let me drink my coffee. Okay, you may ask, but Andre, escrow did not sign the transaction. It's only program-derived address, and we know that program-derived addresses actually do not have corresponding private key. Yes, that's true, but that not means that you cannot actually sign transactions or cross-program invocations with program-derived addresses. It's because when you actually create PDA, one of the seeds that is not specified here but is automatically used within the derivation process is program ID. So that means I can specify here the seeds of this PDA, and the program ID, our program ID to be exact, is automatically going to be included within the seeds. That means we could call this cross-program invocation actually only within our program. So that means the signature is correct, okay? Because no one else actually could derive the program-derived address, as only our program could derive it, because our program's ID is unique across the Solana blockchain. And in order to use the signer seeds, we can include those. Firstly, we need to specify that the function is not, the cross-program invocation function. We are not going to create CPI context like this. We need to specify that we are also going to sign the context. And in order to sign the context with the escrow, we can specify the escrow seeds. Again, the program ID of our program is automatically going to be included within the seeds. That means we could call the transfer function only from our program. And again, this will ensure that the seeds are correct, because if this exactly same transfer would be performed within another program, the program ID would be different. That would mean that the PDA won't be equal to the escrow PDA. Okay, so let's recap. We are invoking transfer within token program, transferring from escrow token account into the side B receive token account. Authority here is escrow. Here are the seeds. There is the bump and there is the amount. Let me check if the amount is correct. Yes, so we are transferring from this token account into this token account. So that means it's the A to B amount, and here is B to A amount. So let me check that the amount from the previous. Yes, there is the B to A amount. Okay. So, and lastly, we also need to specify cancel here, because this is quite different, because we can close the escrow account in this way, because the escrow account is owned by our program, as the PDA is derived within our program. On the other hand, this token account is not owned by our program. That means we cannot simply do close equals site A, and next it won't simply close the account. In order to close token account, we need to invoke again close account function, and I would say I have nope. So I need to specify by hand this function. And for this purpose, we need to close account OK is automatically included, and we need to specify the context. And actually the context is going to be same as for the transfer, as we are going to close the escrow token account. That means we need to actually the context is the same. Again with signer, again we are invoking token program, but this time with a different function which is called close account. This structure is going to be quite different, and the signer seeds again are the same because the authority over the escrow token account is escrow. So let me specify the context, which is CPI context. New with signer program is going to be context.accounts.escrow. Sorry, not escrow, but token program to account info. Next, accounts for this purpose are sorry, we need to use a structure called close account. And within this structure, we have fields such as account destination authority. So account is the account we are going to close. That means it's context.accounts.escrow token account to account info. Next, there is the destination. Actually, the destination is account that is going to receive the rent back. So this is the Alice actually, because she's going to receive the Solana back. Context.accounts.site.a.to-account info. And again, as within the transfer function or within the transfer struct, here on the line 26, there is the authority over this escrow token account, and the authority is escrow. Okay. Sorry. To account info, and we need to specify signer seeds. So let me just copy the signer seeds from the transfer function. Okay. Then this transfer need to delegate the result. Also this transfer. So question mark, and this should be okay. And I have warning here for the min that is unused. A to B amount, B to A amount, and closing account. Let me just quickly copy this because we are running out of time. And within the cancel exchange, as I said, or okay, let me firstly go through the cancel exchange context. So firstly, side A is signer because only Alice can, as Alice initialize the exchange. Again, she can only cancel the exchange. Account needs to be mutable in order to modify the balance because we are going to close the account, basically same as for finalize exchange. We are going to close the escrow account and the escrow token account. Here are the seeds. Then we check the bump. This is totally the same as for finalize exchange. The account is mutable. We are closing. Then we check the correct min and authority. Here are the seeds, and here is the bump. Firstly, let me just paste this here, and then I need to copy the use statement because we are going to use close account. We are also going to use transfer. This is okay. This is also okay, and this is also okay. So this is not anymore triggering the error. And lastly, we have the site A send token account. So let me open the canvas. We are including this associated token account here because, as I said, we are going to cancel the exchange. That means the tokens that were sent from this associated token account into the escrow token account are now going to be sent or transferred back because we don't want Alice to lose any tokens. So she will receive the locked tokens back. Okay. So, and in order to perform the correct checks, the account is mutable because we are going to change the balance. Then we need to specify that this is associated token account. The authority over the account is Alice. The mint connected to this account or the tokens that the tokens that this account holds are from the A to B mint. Hopefully I said it correct. So we need to specify the mint, and yeah, that's it. And also we need to specify token program because we are going to invoke transfer and close account function. So firstly, I'm going to let me copy this transfer, because this transfer is probably going to be the same, or at least the structure is going to be the same. And before I update the values, let me just specify the escrow equals context.account.escrow. The variable holds data from the escrow account. Okay, we are performing transfer with signer because escrow is authority over escrow token account. We are transferring tokens back to Alice, so this needs to be site A send token account. What did I miss? Then there are the seeds, and then lastly, this is the amount, and this is actually the amount which was initially sent from the associated token account of Alice, into the escrow token account. So as we are canceling the exchange, this is triggering error. Why? It's wrong. Okay, this needs to be referenced. As we are transferring the tokens back to the Alice, so we are transferring actually the A to B amount which was initially transferred from Alice. Then we are specifying the close account function. Again, new with signer. We are specifying token. We are using token program. We are gonna close escrow token account. Here is the account that we received the rent back. So site A, and escrow is authority. Again, we need to specify signer seeds in order to sign the invocation context. So right now, this should be correct. Let me check. Okay. Question mark. Let me anchor build. And let me sip my coffee. Okay, we have warning here. So what's warning telling? Finalize exchange. We need to specify the question mark. So what's wrong? Okay, this close account function. So again, anchor build. And lastly, I want to show you the test file in order for you to know how to work with mints and tokens within the test. Or actually, I would say it's almost identical for the front end or for the client side. So firstly, we need to specify a library that is called Solana SPL token, and in order to do that, we can use yarn add the Solana SPL token. This will import the library into our package, so it's okay now. Then we can call anchor test, and while we are testing, I will just briefly comment on the client-side implementation. So firstly, we are specifying Alice and Bob, which are randomly generated key pairs. We can see that the test passed, so hopefully I'm going to comment on that. Then we are specifying the mint authorities. As I said, the mint accounts have the authority, and the authority basically can mint from these mint accounts. That means if let's say your parent is mint authority over any kind of mint, that means your parent can mint you the tokens of the mint. We are specifying a random key pair here. Then there is the amount we want to transfer. Let's forget about this A to C mint authority, as these key pairs and these mints authorities and so on are used later in the test. So just for the informative purpose, it's okay to only focus on the A to B mint authority and A to B amount. Then A to B amount, we are transferring 15 tokens from Alice to Bob, and in exchange, we want to receive 38 tokens from Bob to Alice. To mint is the initial value of tokens we are going to mint for Alice and Bob. So let's say from the earlier example, we are going to mint fresh 100 euros to Alice and fresh $100 to Bob, and they are going to exchange 15 euros for $38. Then we need to specify airdrop because those authorities are going to pay for the means later on, and then Alice and Bob are going to pay fees such rent and transaction fees. Then there is the function for create mint. So this function takes a few arguments. Maybe the most important is the mint authority, which is A to B mint. Then we have freeze authority, which is optional. This freeze authority can actually freeze token account. So that means if the token account is frozen, we cannot perform transfer from the token account. But this is, I would say, maybe a little bit of advanced stuff. Then there are the decimals. Why did I use 9 and 6? Based on the experience is most common value. And lastly, there is the optional keeper. So the resulting mint is going to have random public key. So these are the functions for the mints. Again, for the mint, then we have token create account. The most important part here is that if you open create account, you can see that there is the 1 to 5th argument, which is optional keeper, and this optional keeper is defaulting to the associated token account for the mint and owner. That means we specify A to B mint, Alice public key, and this is actually the mint, this is actually the owner. If we do not specify the 5th argument, this function will automatically create associated token account address. So the associated token account address is actually PDA derived from this mint and this owner. The second argument is, or the second parameter is Alice, which is the payer for the account creation. Same goes for the second ATA, which is used later on within the test. Same goes for the Bob, which is actually associated token account, but from the other side. So you can see there is the mint and there is the owner. Lastly, in order to mint, as I said, we are going to freshly mint $100 and 100 euros. So we can perform token.mint2. There is the Bob, which is, I would say, payer for this mint. Then there is the mint address from which we are going to mint. There is the token address, which is going to hold the tokens. Then there is the mint authority, which needs to sign the transaction, and there is the amount. There is the amount we are going to mint initially. So we are using to mint, which is $100 or euros in whatever case you want. And that's it from this side. I ran out of time, so you can see that all the tests I have passed. We wanted to exchange 15 euros for $38. We initialized the exchange. Now you can see escrow token account holds 15 euros, and side A balance after initialization is 100 minus 15, which means 85. And then after finalized exchange, we have 38 tokens within the side A associated token account. That's the token account for dollars. And on the other hand side, we have 15 euros within the side B associated token account for euros. So we successfully finalized the exchange, and it went actually securely, and no one scammed anybody. Within this lecture, we went through the basics of the token program within the Solana Program Library. I also showed you how you can use the token program within your own chain programs. and also the idea behind communication with the SPL token program from the off-chain side, aka from the client side or test side. Now I want to thank you for your attention, and I hope you get inspired for the final projects. And of course, I look forward to your submission. So bye and see you next time.